teams and who are the only representatives.
Hello, Natalia. Hi, everyone. It's good to be here. Thanks for inviting me. I'm sharing my screen. Hopefully you can see that.
We do already see the presentation.
Okay, great. I'm going to talk about this scary subject, and I'm not sure at what level of, like, how familiar you are with API specs, etc. So I'm going to try to figure this out as I talk. I do include some code samples later on in this presentation, but they are more to illustrate and to walk you through. You don't have to read code, but maybe this will show you that it's not as scary as we all think, being technical writers and rather writing about applications. Maybe we could start tinkering with some code. I would like to start with the poll. If Natalia, if you could bring that up on the screen, because I want to find out how many of you have had to do with any API docs. So have you written API docs? No, never. Or maybe some docs to go with the auto-generated Swagger UI? Or, yeah, I wrote docs, but we did not provide any auto-generated stuff. Or, yes, it was my responsibility to write docs and deploy them along with auto-generated docs and everything.
So the poll is running. You probably don't see it on screen. And people are still voting, and after the end, I will show you the results.
Okay, yeah, I'm curious. I'm really scared right now that my presentation is going to be completely out of everyone's area of interest, but hopefully you anticipate that this will be a little bit like that. API specs, they're not so bad. A couple of years ago, they became the most, the technical writers working with APIs were the best paid, according to a survey run by Tom Johnson, which I think the survey was worldwide, not just the US. So hopefully this reflects some reality.
People are still voting, and just in a second, I will show you the results. And from what I see, it's not totally, the presentation is not going to be out of scope. So the people are really in the topic.
Great, great.
So there you go.
Okay, so we're pretty spread out. There's a big majority of people who have not written any API docs. I hope those people want to write some API docs or will write some API docs.
Yeah, I'm sure they will, and this gonna hit them one day.
Yeah, I mean, I'm going to talk about how or why my company, Guidewire, started writing started publishing APIs, but we'll get to that in a second. Let me just tell you a couple of words about myself. My name is Pawel Kowaluk. I work and live in Poland. I've been in the tech comms industry since 2008. I'm part of a podcast team on techwriterkoduja.pl, which is in Polish. If you understand Polish, maybe you want to check out this podcast. You might also want to check out the site. There are some code examples there. There are some articles, links to articles which you might want to read. Maybe Google Translate can help you if your Polish is not great. I'm also part of ITCQF, which is a certification organization, which can, if you want to get certified as a technical writer, you can take a course and pass the exam and get your certificate. My hobbies are speaking at conferences, and I like tinkering with JavaScript and Python. I'm not a programmer, but I'm a technical writer who tinkers, right? So I just, like to write some code here and there. Now let's talk about why APIs and how Guidewire got into APIs and why we had to create the docs. So Guidewire is an insurance platform with 20 years of development. I'm not saying that to say how fantastic Guidewire is. I'm just saying this is a lot of code that was written over the years, and it was written a long time ago. Like the Guidewire platform resolves a lot of issues with insurance. And those are sometimes complex issues. For example, if you're trying to insure a house in Germany, there's some regulations in Germany that talk about areas of risk, which are on the map, and then Guidewire platform can integrate with the government database to look up the address of the house you're trying to insure and grab the risk percentage from the government database, and that influences the price of your insurance. So there's hundreds and thousands of tiny little things like that, which the Guidewire platform has solved over the years, and which now you can take advantage of it, and which you can benefit from. And this application was written in maybe not the most future forward thinking way, because the user interface and all the inner machinery is one big application. It does not use the typical separation of interface and business logic. And that's why it's been a little bit hard moving forward. There is some separation, but it's not very strict, it's not clear, and it's not always there. So this huge machinery that we developed is basically fused with the user interface. Meanwhile, the business world has stopped being just people sitting at their computers, and this is consumers and this is business people. We're doing this and using the applications in their workplace. Like, it's not always a user at a desktop. We have moved from the desktop-centered world into a mobile-centered world. So you're on your phone more often than you're on your computer, and this is true for people who are trying to buy insurance. It's true for people who are trying to rent a house, get a ride around the city, find a flight, etc. Like any kind of thing that you're trying to sell online is going to be on the phone. This is a problem with our system, which was not created in a time where there was a lot of mobile phones. There was a desktop-centric system, and also it's a problem for our customers who try to use our platform and want to expose some functionality to their customers. And we really needed to shift towards, grabbing a piece of our application, like creating a new insurance policy and displaying that on a user's screen, but branded for the company who is selling the insurance, right? So the company who is selling the insurance is our customer, and they want to put their own spin on how they sell this insurance, but they want to use Guidewire in the background. This is a typical case for an API, right? So you have a big application and it exposes some functionality through the API so that you can write another application, and your application can use this functionality. So we could create an API which exposes every piece of functionality, but that would be a huge API. It would be as big as the application, and frankly, it would be much too long to use. Just even from a practical perspective, if you're trying to read one API spec, or if you're trying to create docs for one API spec which exposes all of the functionality, it's going to be hard to use, and the paths are going to be very much embedded, and the commands are going to be long and convoluted, etc. So decided to build APIs for smaller functionalities. Each little functionality has its own little API. And then if you multiply that by the number of applications and the versions that we have, that gives you a lot of different specs. So, and this is great because some customers want to use just one little interface, or maybe 3 out of the 50, right? But this also shifted a lot of the responsibility to the documentation team.
Sorry to interrupt you, but do you change slides or just one, because we see one picture on the screen?
Okay, I think my thing froze. Let me unfreeze.
Oh yeah. So we see the dialog, and now it should be working, right?
Okay, yeah, hopefully. Right, so they shifted, we shifted the responsibility to the docs to make sure our customers can find what they're looking for, and Um, and then docs started thinking about how we can implement that. Um, Now it was hard at first because we didn't really know how the users are going to be using those APIs, and we also had to educate ourselves on how users typically consume APIs. What we've gathered around the market, and we have some people who do have experience, so we use their experience. But we had to throw this against our users and interview them and figure out what they are going to use. But we figured it would be good to have one directory, one website, where you could have links to all the different APIs and read the spec for each individual API on the page. And then put that on our documentation site as well, right? So there are a couple of challenges here. One is collecting all the APIs from everywhere, and another one is putting that into an existing infrastructure, which if your company is just starting with APIs, this might be the same challenges that you would be facing, right? Because you already have a documentation site, and then you also want to, and you want to publish your specs into that site, but then you also want to um, display them in a spec native way. You wouldn't want to be writing documentation for all the specs, because there's ways to automatically generate documentation, which I will talk about in a second. So one of these popular ways of displaying spec information, API spec information, is Swagger UI. How this works for people uh, who have never used it is an API specification is usually written in the form of an open API spec, we call it, open API, either a JSON file or a YAML file, which lists all the possible endpoints. And then it lists all the operations on those endpoints. And then it also gives you the parameters, examples, responses, all that information, all the information that you need when using the API. So for example, in a pet store, an endpoint would be pet. And then looking at this spec here, you can tell that you can add a new pet, or you can update an existing pet. If you use the post operation, you will add a new pet, and if you use put, you can update an existing pet. And then there are other things you can do. For example, you can find pets by status. For example, some pets are sold and some are available. You can get pet by ID. You can update the pet by ID. You can delete a pet by ID. And you can upload an image to a pet. Maybe you took a photo of a puppy and you want to add it there. So this is and then this Swagger UI page lists these endpoints. If you click any of them, it expands and it shows you additional operations that you can, or additional things about this endpoint. So if there are any additional parameters you can enter, or what the responses would be from this endpoint. And this is the most popular way of presenting APIs. But there's one problem with it, and I can illustrate this in a second. The problem is that Swagger UI likes to load very slowly. And this has been a problem with our platform, because the Guidewire specs, even though there are so many of them and they are so fragmented, still each one of them is quite long, because there are a lot of operations and parameters. So after looking at the market for a little bit, we found Redoc, which is another format of API spec documentation. And just like Swagger UI, you grab your open API spec and you just feed it into Redoc, and it displays this wonderful documentation, which is mobile as well. It's free to use, just like Swagger UI. It's modern and it looks fun. It's basically the same kind of thing. You have your endpoints here. You have your operations here on the left and the description of the operation. And you have the endpoint here. And then you have all the possible parameters and the schema for the request. You have all of that here in the center, and then here you have some samples, which you can display in different options, different variants, etc. Whatever you have in your spec. And since we want to integrate with our existing page, documentation page, we had to find something that could put the files up there. Now, our existing documentation page is a static site. There's a lot of different static site generators working together to create the page. So we needed to use something like that. Now, Next.js is a static site generator and also a framework. Now, if you've never worked with static site generators, basically it's an application which does some processing in the background, and then it creates a set of HTML files which can be served on a very simple web server. So if anyone's ever worked with data, that creates static sites. If you run some data files through Data Open Toolkit, you get an HTML site or a web help. Same goes for example, Matcap Flare or Adobe RoboHelp. These editors generate static sites for you, and you can upload these static sites to a web server and display them. So for our specs, we decided to use Next.js because it's a very configurable and expandable platform. It uses JavaScript, and because of that, it connects. It's very easy to integrate with Redoc, and it's super fast, and also it's super easy to find documentation, and the documentation for Next.js is very easy to understand, very easy to read. It's also free and open source on the net, so if you want to grab it, you can do it right away. And if you know some JavaScript, it'll take you maybe an hour to get a static blog up there or a static documentation site. So what we did is we grabbed our specs, fed them into Next.js, and then we created our site. 1, 2, 3, that's very simple. Well, it's not that simple, as you can imagine, but this is the end result right now. So the features of this page are that has the branded header, and in the header you have the download button, which we configured to, you can download all the API specs for whatever is being displayed here, and then we group this by version and by applications. For example, Billing Center latest has these APIs. Some of them are marked as system API, and then if you click the button, you get into a specific API spec displayed in Redoc. And we changed the interface a little bit. I will talk about that later. But pretty much your all your endpoints are here, and the operations, and then there's descriptions and stuff like that. And we are still in the same application, meaning we have the header from the main app, but it's a static file. So we're not doing any server magic here. It's no iframes and nothing like that. It's a static page. Okay, so let me walk you through how this works in more detail. There's going to be a little bit of code. If you're scared by that, don't worry. It's not as bad as it looks. Every application that we have exposes this endpoint which lists all the available APIs. So for example, Billing Center tells us that there's an endpoint called APIs, and it has its own spec here. And we also have another one which is under System Database, and so on. And there are a lot of these. So what we do is, for each of these listings, we do a simple fetch in JavaScript, and then get the response into the JSON format. And we save these files locally during build time. So there's a specs folder in our project, and it just saves all these different files, and there are several dozen of these files. And then we build static routes. What does that mean? In Next.js, if you export a function called getStaticPaths from a page which uses those dynamic routes, Next.js will statically pre-render all the paths specified by getStaticPaths, which means that, like we're turning our dynamic process of discovering what APIs there are into a process of building static files. So let me show this to you again. This is very much alive, right? We had to figure out where these endpoints are within the company, and they are being developed, right? So new versions appear, new APIs are being added all the time. Maybe there are new endpoints created and somebody lets us know when we add it, but this application is very much alive. But using this pipeline, we are able to always display all the docs for all the versions of all the APIs that we have at the company, which is, just pretty amazing for a very small documentation team working on such a big project. Okay, so we're getting these statically pre-rendered paths like this. We create a function called getAllSpecIDs, collect the file names from the specs directory, the directory we just created with all the JSON files. For each JSON file, we return an ID from this file name. Simple stuff. So as a result, we get a list of file names. And then the getStaticPaths function, which we export from our page, uses this method to get all spec IDs, and then it just returns all those paths into the context. So that creates all our static routes, and we are ready to deploy. Next.js gives us 3 deployment options. The first one is their branded Verso platform, which is free for for hobbyists. If you're trying to use it for business, you have to pay, but we are not using that. Another option is a Node.js server. You can build your application and then start it so that it's served on a Node.js server or with a Node.js server. But for that, you need a live application to be running on your server. This is not what we're trying to do, right? Remember, our site is a static site, right? So we just want the files. So this is the third option, exporting static files. Again, this means we will just get a very simple folder. One of the files is called index.html. There's a subdirectory, and there are all of our specs are in there as HTML files. To do that, we update our build script to first download the specs. This is the first operation. Then build the Next.js website and then export the static files. This is just one command and it gets the whole job done. In the out folder, it generated the index.html file, and then in the specs folder, we got the pet store spec, the Uber spec, etc. Right? Whatever specs we had, they would all be in here, hundreds of files. Next, we're working on displaying the spec on the page, and in Next.js, if you export a function called getStaticProps from a page, Next.js will pre-render this page at build time using the props returned by getStaticProps, meaning that this page will be, as it's being built, all the JavaScript and everything is going to be compiled into a static file and placed in a folder. So you will not be reusing JavaScript packages from anywhere else. It will just be one file that you need, and you can open this file and it should work. This is our getSpecData function. We pass the ID of the spec. It grabs the ID, the JSON file, which corresponds to this ID, reads the file contents, and then just returns the file contents as the result of the function. And this is the getStaticProps function, which I mentioned before. Use the Next.js to render a static page. We grab the spec data, and then we just return the spec data. We create a spec object by parsing the file contents, and then we just pass it into the Redoc standalone component. This page uses React, and we use the Redoc standalone component in React. We pass the spec object prop. We pass some additional options. And we can also pass a function which runs after the component has loaded, and I use this function to customize the look and feel of the page. This is what I would like to talk about next, customizing the Redoc styles. So this is a typical Redoc page. There's a left panel with a search function, and then it lists operations with descriptions of endpoints. And then the operation and the endpoint is here, and the code sample is here. So this is a little confusing. If you've worked with Swagger UI, you're used to seeing the operation endpoint first, and then getting more information. This is kind of split between 3 panels. We decided this was, I mean, we got feedback actually that this was a little confusing for our users. So we wanted to achieve this. Very linear, top to bottom. You start with the operation and endpoint. Then you get the all the information about the spec, and then the spec example. Nothing in the left and right hand panel. It's all in the central panel. To achieve this, we cannot, I mean, Next.js exposes a globals.css file which influences the styling of the entire application. And theoretically, we could use this to style our specs, but but Redoc uses dynamically generated classes. So you cannot use them in a static CSS file. Like if I said, okay, any div that has the bh and xwf class should have this kind of style. If I try to do that, next time I build, the class is going to be different. So I cannot kind of externally hack it. What I realized as I was creating this presentation is I made a mistake in judgment. I could actually statically style them if I created some more creative selectors in CSS, like because there's a class here called API content, and it wraps the entire content of the API, right? So I could have created selectors like this, like going into a specific div, or maybe grabbing all the buttons within the API content class, or anything else that would be better than what I actually did, which is I wrote this function, which I'm going to show you from far away because I'm not very proud of it. But I injected this function into the Redoc standalone component. This function runs after the spec is loaded, and then it updates the component styles. So if you're reading this right now, you see that we find a button, and then we update the font size, the font weight, the color, the padding, etc. Which is, I'm not proud of this part, but I decided to be, full disclosure, I decided to be honest with you guys about the mistake that I made. This is probably one of the least stable parts of this application. In the next iteration, I'm going to get rid of this and use static styling. It's going to be much easier for everyone. Okay, I'm already in the summary, which went a little quicker than planned. So the good parts of using Next.js is that Node.js lets you download the specs, and it's it's very quick. It's asynchronous. So if you have 60 specs, you can be now downloading 60 specs at the same time if you feel that's a safe operation. It doesn't take a lot of resources to do that, and it also it's easy to find help on the internet. If you Google stuff around Node.js, you have help everywhere. Next.js creates a very fast static site compared to something like Swagger UI. Next.js with Redoc is lightning fast. Pages just click into view, except for some of our specs which are extremely long and they take a second or two to load. And then Redoc really has nice styling. It's responsive. If you're okay with the out-of-the-box look, you don't have to customize anything. It's nice and clean. Building and deploying is just one command. It works in any CI/CD as long as you have the right Docker image or as long as you have Node.js installed. You don't need anything else. But there are some bad things. It's not that easy to change spec styles and layouts if you want to do that, as demonstrated by my example of trying to hack the static styles. And here's an interesting thing. If there's an error in the spec, Redoc does not display it, it displays an error. Why is that a problem? Well, as we are working on more and more specs, some of them had errors in them, as they were in progress. Until the error is fixed, so for example, there's a reference to in the spec, there's a reference to some endpoint which hasn't been implemented yet. If you have an error like that, your spec page just shows error and then it lists the reason why there's an error. It will not display any documentation. Swagger UI will display your documentation. It will just show a broken link, or it will not display a property or something like that, but the rest of the documentation is there. So this is perfect for production readiness because it's an extra test. So if you try to display specs and they don't render, it means there's a problem with the specs. But on the other hand, it's not good for internal environments if you're trying to display in progress specs internally. You're much better off using Swagger UI. But then at the same time, you could use the same approach with Next.js, just use Swagger UI instead of Redoc. And I've added an example on GitHub. We will be sharing this presentation, right? Will people be able to click the link, Natalia?
Yes, if you like to.
Sure.
I can see that.
Sorry?
No problems with sharing.
I can also post the link in the chat.
Yeah, please.
If you're, where's the chat now?
You can do it afterwards, I think.
Okay, sure, no problems. Yeah, so if you want to look inside the code, it's a free example on GitHub, which we removed any guidewire stuff from it. It's just a generic one that shows a pet store and the Uber API. So feel free to experiment with that. If you have ideas on how it could be improved, we would welcome any pull requests. Okay, now it's time for questions. Do we have any?
We actually do. For example, when you say super fast, could you be more specific? What is the build time for the site?
Yeah, so the build time is usually between like 5 and 20 seconds building the site. Getting the specs is about like if we try to get all of them, that's like 45 seconds because some of them are pretty big. Like I said, it's asynchronous, but it takes a little bit of time to download them. It depends on like how many specs you have. But it's up to 20 seconds to build the site. And if you're running it locally, it opens up after like 2 seconds and then it reloads live because Next.js has a very quick hot reload option.
Thanks. And another question from the same person. Do you use Git and CI/CD in your pipeline to trigger the build in Vercel?
Yes, yeah. So we use Git to store the repo and we use TeamCity as our CI/CD. It's not linked to changes in the specs, but we could. Like we could set a trigger on whenever a new version of a spec is added, but we want to have more control. So we run the build at a specified time when we want to publish a new version of specs. So we've heard from all the teams the specs are ready to be published, then we hit the button. The only automated builds we have is when we change anything to the application, meaning to the site, right? So we update the styling, we update some of the logic, whatever that rebuilds automatically and that refreshes automatically.
Thank you. One small question from me. Oh, I see another question coming in the Q&A. I understand you need to be relatively proficient in JS. Any other coding languages?
So for this particular tool suite, it's JS, right? It's because you're working with Next.js and Redoc. But there are options. there's a page called staticgen.org, which lists all the static site generators, and you can filter by
Thousands.
language and you can find them.
Yeah, there are thousands. And you also mentioned that there is a pretty small team that you have who keeps on running all this stuff. So how big is the team? And how much did it take you to decide on how you, the tools that you selected and make this happen?
Yeah, so this is a Matryoshka question because the team is a little bigger. It's about 30 or 40 technical writers, but only 3 people working on tools and deployments.
Mm-hmm.
So this is a smaller team, the smaller team within the bigger one. And there's an even smaller API team, which is I'm the only person working on tools. We have one technical writer who is a consultant on APIs. And
Mm-hmm.
then we have PMs and other people who are on the API side. So that's the small team. How long did it take? It took a number of iterations. So the project started last year, and initially it was a whole different suite of tools, and we just put something up there for people to see, and they said Swagger UI doesn't work, Redoc doesn't work, then we need more specs, we need fewer specs, we need specs from here, specs from there. So like over the iterations, over the few months, we finally arrived at Next.js. Once I was on Next.js, like once I figured out I want to use that, it took
Mm-hmm.
me one day to replace the entire site with just Next.js. And then it took me a couple more weeks to iron out all the little, it's always like that. Like you can do 90% of the work in one day, and then it takes you a month to do the rest of the work. But yeah, but it's pretty simple to use and pretty quick.
Would you recommend Redoc and Next.js for others to use? That's another question in the comment
Sure.
field.
I recommend Next.js and Redoc for other what?
To use for others.
Sure.
Yeah.
Yeah, I would highly recommend them. I found that Redoc really has nice documentation, and it, like I said, it loaded really quickly. So I do recommend them. And Next.js is, frankly, is one of my favorite platforms to use, and I've only used it on this one project so far.
Yeah. Well, what I have to, yeah, do you have something else to add? Nope.
Sorry?
I had a feeling that you have something else to add, but apparently no. And I want to thank you for the talk. And I really hope you still will post the link into the chat field so that everybody can follow the your Git repo.
Sure.
And thank you for your time today for us.
Thank you,
We
Natalia. If anyone has any more questions, feel free to reach me on LinkedIn.
yeah,
Um,
and
and
people are grateful in the chat. So so it does make the difference for everybody, and I hope that people from my company, at least the API specialists, also had the informative pieces from your talk.
thank you
Thanks a
very much.
lot. Thanks a lot. And what else I have to say is that is all for day one of the conference. We will meet you tomorrow on our Ukrainian speaking day with 2 more topics from our lady speakers. And in the chat, I'm also posting an email address so that you can say what you have to say, post your comments, and um, you can also